Hey everybody, it's Mr. Odom, and today I am going to review Chapter 3. So we're going to be having a test on this chapter soon. Make sure you get all your work done. Can't take the test unless all your assignments are in. I recommend that you work out the exercises that you'll see here in your composition books. Gives you a little extra practice, and I attach the answer key at the end. So it doesn't make sense to stop the video right now or fast forward the video so you can go see all the answers and put the answers in the questions. That's not going to help you. So make sure you have your composition book, your pencil, ready to go, calculator, and practice these problems. You'll see problems like this on your test. So in section 3.1, we learned how to simplify algebraic expressions. Okay, that was kind of the key idea, was simplifying algebraic expressions. We also learned how to identify terms and like terms in an expression. Okay, remember one of the things that I would do when I wanted to identify like terms is I would use boxes and circles. Okay, so that's how I do it. The textbook does it a little bit differently than how I do it. And you can follow along how they do it if you want. If that looks easier to you, that's fine. Simplifying algebraic expressions, I did give you a process for that. Okay, so let me, you can pause the video and go through this example and see how the textbook does it. But I do show you a different way to do it. I give you a recipe. Okay. I did work out one of the problems here, number 2. That one's done. It's up here. So you can see how we list the terms in this expression. And then that makes it easy to identify the like terms and put them together. Pretty straightforward stuff. For simplifying expressions, this was the process. Okay, step 0, get rid of the parentheses. So if you have like number 8, number 9, number 7, there's parentheses in those expressions. You need to get rid of them. And in all 3 of these problems, we can use the distributive property. So remember the distributive property, 1/8 times that, 1/8 times -8, 3 times 2, 3 times q. So I do an example down below, so we'll go through that. The second thing we need to do after we get rid of the parentheses is identify the like terms. Which terms are part of the same family? Remember, all constants, so all integers, all whole numbers, all fractions, all decimals, they are all like terms. They are all part of the same family. Step 2 was put the like terms next to each other. So think of your algebraic expression, as a puzzle. You've identified the terms, and you can pull those pieces apart and put the like terms next to each other. And then you add or subtract the like terms. So that depends. Do you need to add them or subtract them? And then there's 2 questions you have to ask yourself. You have to say, self, are there any parentheses? If there are, then you have to go all the way back to step 0 and get rid of the parentheses and then go through all this again. The next question you have to ask yourself, are there any like terms? If so, then you need to go all the way back to step 1 and identify the like terms and put them next to each other and combine them. Okay? And then step 5, if the questions that you just answered are both no, you say no, no, then your algebraic expression is in simplest form. Okay, so let's look at a couple examples I did. Number 6 on the left. So step 1 or step 0, I don't need. There were no parentheses. So I just move on to step 1. I identified my like terms. 3/5 x, -3/20 x, they're like terms. And then these 2 constants, +19, -7, those are like terms. The next step, I put them all together. You can see how I did that here. I just put the boxes next to each other, and I put the circles next to each other. And then I combine them. So I combine the like terms in yellow, and I got this, and I got this. How did I get that? I leave that to you to figure that out. If you need help with that, ask me in class. And then I combined positive 19, I subtracted 7, I get 12. All right. So this is my final expression. Is it in simplest form? Well, are there parentheses? No. Are there like terms? No. So this expression is in simplest form, and it is equal to the expression that we started with. Okay. Number 8. For this one, I needed to use the distributive property. And so you can see the steps that I took. You can see the canceling that I did, and I encourage you to cancel whenever you can, okay? So I did some canceling, and then I identified my like terms, which were just those two constants. They're already next to each other. I combined them, and are there parentheses? Are there like terms? No. So this was a no, no. Yes, this is in simplest form, and this expression equals the one that we started with. Okay. All right, let's look at section 3.2. In this section, all we're doing again is we are simplifying expressions. We're looking specifically at certain types of expressions, specifically linear expressions, but we are still just simplifying. Even though it says find the sum or difference, you can think of that as saying, hey, simplify the expression, put it in simplest form. All right, so let's look at a couple examples. For number 10, and I didn't work all these out, I got them to a place where you can come back up here and follow the steps. All right. So the first thing I did was I look in front of the linear expressions. The linear expressions are in parentheses. So 3c plus 9 is a linear expression. C minus 4 is also a linear expression. So I look in front of them or to the left of them, and I see that there's no numbers there. Okay, I don't see a number. So then if there's no numbers, then you can just drop the parentheses. Okay, you can just drop them. All right, and that is when you are adding. So if you are adding linear expressions and there's nothing to the left of either expression, then you can go ahead and drop the parentheses. And then, so I have this expression here, and then you just follow the steps. Identify the like terms, put them together, combine them, ask yourself some questions. For this problem, number 11, I see I need to use a distributive property. Why? Because there is a number in front of each one of these. 2/5 is in front of this linear expression, d minus 10, and negative 2/3 is in front of this linear expression, d plus 6. So I use the distributive property, and I get it to where there are no parentheses. And then all you have to do is follow the steps. Identify the like terms, put them together, combine them, ask yourself 2 questions. All right. Let's move on to solving equations using addition or subtraction. So there's an example here. You see that process. The one thing that the textbook doesn't do that we do is we put that line down the center to get us to think about a scale and have everything balanced. So that's kind of how I showed you how I solved these problems. So I solved a couple down here, and then you guys can do the rest. I only checked the first one to show you how to do it, but you should also go through and check your answers. So number 16, so I did this one, and you can see what I did. I have the variable p. I'm subtracting 3 from it. What's the inverse operation for subtraction? It is addition. So I add 3 to this side. And the addition property of equality says if I add one thing to one side, I have to add the exact same thing to the other side, or else if I don't, then the original equation is no longer equal. And then I just do the math. All right. And then you see what I did when I checked it. I wrote down the equation. And then what did I do? I evaluated this expression, p minus 3, when p equals -1. So I put -1 in there. I substituted. So on the left-hand side, I evaluate that expression. I want to make sure that on the left-hand side of the equal sign, I get the same thing that's on the right-hand side. So that's all you're doing. All right, number 21. Same thing here. I needed to add 5, 6. Why? Because I'm subtracting. And so I add 5, 6 here. I do the math. How did I get this? Right? If you don't know, then you need to come see me so we can figure out how I ended up with this. So the answer is -1/24. You'll see that down in the answer key. We got it right. Then we learned how to solve equations using multiplication or division. And you can see I did a couple problems here. I did number 25. So y is divided by 7. So then I have to multiply it by 7. I'm dividing by 7. The inverse operation is multiplication. And if I multiply the right side by 7, I also have to multiply the left side by the same thing, or else the equation is no longer equal. I do the math. Remember multiplication, same sign, positive answer, different signs, negative answer. Over here, I have -z divided by 4. So that negative is important. I need to make sure that I get z by itself, which means I need to multiply by a negative value, whatever that value is. That's how I get a positive value at the next step. Here again, I'm dividing by 4, so I have to multiply by 4. And I do that so that the denominator cancels with the numerator, and I get z all by itself. So I multiply this side by -4. I have to multiply this side by -4. And you do the canceling, and you get 3, which makes sense. What number is going to go in here so that this left side of the equation is the same as this side? Well, it has to be 3, right? -3/4 equals -3/4. Then we talked about solving two-step equations. So now my first choice is I need to use the addition or subtraction properties of equality. And then for my second choice, I'll use the multiplication or division properties of equality. You can see in this problem, I use subtraction, use that property of equality first. Why? Because I was adding 7. Here, I'm multiplying by -6. So I have to divide both sides by -6. And I get my answer, and you can see how they check their answers. So number 33 and 34. So we just walk through this. Here I'm adding 6, so I subtract 6. Since I'm subtracting 6 from this side, subtract 6 from that side. Here I'm multiplying by -2. So c is multiplied by -2, so I have to divide by -2 to cancel out the -2 in the numerator. So that gives me c all by itself. Since I divided by -2 on the left-hand side, I need to divide by -2 on the right-hand side, and you can see my answer. For number 34, I need to use a distributive property. This is not in simplest form, right? So we want to make sure that on both sides of the equal sign, I have expressions, right? I want to make sure that they are in simplest form. So for 34, it's not. So I use a distributive property. Now it's in simplest form. There's no like terms. There's no parentheses. And it's a two-step equation. And so I walk through the steps. I'm subtracting 12, so now I add 12 to both sides. And then I end up with 9 times w. So since I'm multiplying, then I need to divide both sides by 9. If I don't divide both sides by 9, it's no longer equal. And my answer, -8 divided by 9, I don't need to do that in my calculator. I can just write that as a fraction, and I put the negative sign in front. So that is the answer. You'll see down here, and I'll stop the video down here at this part, you can see that the answer key is here. So you can go back and check your answers. And again, I recommend working these problems out. That's the only way to get better at this stuff, is to do it, is to practice, okay? So That's all I have for Chapter 3 review. This is Mr. Odom, and I am O-U, oh my gosh, T, out.